Hello, everyone, and thank you very much for joining me in this session, where I will present our paper, Systematization of Knowledge, Data Privacy in Virtual Reality. I give my thanks to my colleagues at UC Berkeley, Vivek and Don, and I have to read a disclaimer that the information and views set out in this article are those of the authors and do not necessarily reflect the official opinions of the institutions. In this talk, I will give you the context and our goal. I will give you the presentation of the different taxonomies on attributes, attacks, and defenses, and then other insights that I think you might find useful. It is a systematization of knowledge, so it's very hard to put everything on the presentation. So I encourage you to read the publication. The context. So virtual reality has gained momentum in recent years. A couple of years ago, Facebook rebranded itself from Facebook to Meta, as in the metaverse, which is intended to be a new medium for accessing the internet, and this access will be through virtual environments. And while that has been obscured by the hype on AI, the potential is latent, and other companies see how the future could evolve. And for example, Apple released their first ever virtual reality product. Now, privacy concerns are likely to be even more prevalent in the new Web3. So the Web2 concerns would still be in Web3, but because now you have new sensors, they are qualitatively different, then new privacy risks come, and then the attack surface increases. So there's already research showing that there is more personal information and sensitive and it's observable. Luckily, there are also defenses against these attacks. And I here give you two definitions so that you know what I mean when I talk about virtual reality. In this context, it's a computer simulated interactive environment experienced in the first person, and a state of privacy is a lack of a breach of any individual sensitive data attributes via identification and or profiling. So what is our goal? So we want to systematize knowledge on the landscape of VR privacy threats and countermeasures. And with this systematization, we taxonomize data attributes, protections, and adversaries in the literature. And we did all this by collecting and filtering 74 publications. So we hope that by focusing on highlighting the clear outstanding opportunities, we hope to motivate and guide further research into this increasingly important field. This is to get an overview of the context in which we are. So you have users that wear different devices, and the devices are registering the inputs from the human and also the environment. This data will be ingested by applications that request that data through APIs. And then they render the frames and different signals, and then they output that to the user. If you are in a multiplayer setting, you also need a server, and then you interact with other users. So there are attackers throughout this pipeline. You have the hardware itself, but you also have the client adversary, so the application developer, also the designer of the content that is within the application. Could be malicious. It could hide puzzles that reveal personal information without the user knowing. Then you have the server who gets a network telemetry, and then other users that may perform social engineering attacks. And the data fidelity and adversary capability decreases from left to right. There are different points where you can add protections. Here you see them at the different key points. And these protections cover privacy, security, and safety. And security and safety are covered in other literature. We focus mainly on privacy. So after collecting the 74 studies, we saw what the researchers were taking from these devices and what they were inferring. So you have primary attributes that they measure directly, like body skeletal information, and then you can directly measure height. And then if you do some deterministic calculations, you can find other attributes, and we call them secondary, like your wingspan. Now you get the direct measures of your hands, and then you can calculate the wingspan of the user. And all this is used to infer identity, so to single out individuals amongst others, and also to do profiling, where you can perhaps gather data to infer age, gender, physical health, and so on. Here we cluster the different data in different classes. So you have your spatial and inertial telemetry, which are big ones. You have audio text as well, video, physiological signals, which are very critical. And then you have system and network information, which is also prevalent in other systems. And then behavior. So even your avatar is releasing information about who you are, right? So that has to also be put into consideration. We took all the attacks from these papers and we classified them based on device, what attributes they use. You can see that most of them either do geospatial and inertial telemetry, or they focus on video or physiological signals. Then half do profiling and identification, and most of these attacks come from a client adversary. Some interesting stuff from these attacks is that the most accurate identification attacks rely only on the headset and handheld controller, so they only need position and acceleration. Profiling attacks that predict critically sensitive information, namely emotions, rely on health sensors. And once health sensors become more available to the public audience, the privacy concerns will be higher, and the countermeasures should already be in place. So there is plenty of work for researchers to do. There is a lot of these VR attacks are very invasive. Just look at the motions that they can gather from health sensors, or from like recording your face as well. And in terms of how easy these attacks are, social engineering attacks in virtual reality are easy, and also these attacks that we gather are not rocket science. So servers and clients could perform them, and given that the standards of privacy are low in the ecosystem as of now, they might, as of today, get away with it. And the effectiveness of these attacks is high. So the most effective identification attack targets gait, so the way you walk, and they get 98% accuracy using only the inertial measurement unit. The identification, again, remember, is to single out one individual amongst many. And the most effective profiling attack inferred gender, age, and ethnicity with close to 100% accuracy, using variations of support vector machines and random forest classifiers. And the data was wide. So different aspects were gathered throughout the game, and it was a puzzle. And then based on the results of how they solved the puzzles, they would gain more information. We did the same for defenses. You can see that most of the defenses, unfortunately, focus on video, and they also protect the input to the device. The defenses can be classified in different types. So you have the perturbations, where they add noise, information abstraction. So instead of relaying the raw video data, they relay an abstraction. So just the shapes that build the table, for example. You have recognizers. So if you see if the device sees an individual in the background, they might obscure it. Analyzers, platform features, like for example, if you're in a virtual environment, only X persons can go into this area, and authentication mechanisms as well. And just to move to RQ4, which I think is the most important one to give the message, is that if a researcher does work on defenses, they should account for usability. So sometimes privacy comes at the cost of usability, and it should be accounted for when researching. We also mapped out all the privacy attacks the most prevalent privacy attacks to the most suitable countermeasures, and we outlined the gaps in the research so that you can go ahead and produce them. We also saw that only 21% of the repositories were functionally operative, which is low. And also a quote from a study called Overseen said that 70% of the VR data flows from the most widely adopted VR device were not appropriately disclosed. So there's a lack of transparency in the ecosystem. This is what I meant before. And this should be tackled. Now, as the last thing, is that based on all these research, we concluded on a few guidelines for an incognito mode for VR systems. First of all, is that there should be a privacy-aware hardware design, where if you leave the device it will immediately stop recording or sensing information. Your OS has to sandbox applications, and it should monitor applications so that they don't behave in manners that are not were not thought to be. On-device processing, so if you can compute things locally, is better from a privacy perspective. Browsing and communication protections, so end-to-end encryption, and also the incognito modes that exist today could be also brought here. You can add all the pricing and technologies that have been discussed during the talk as well, and embed them at the application level, hardware level, and so on. And then the privacy settings for users have to be intuitive, transparent, without dark patterns, and the user data controls have to be there too. All right, this is the end of the presentation. Thank you very much.